That's my new greeting. Okay, we're doing a review of the Aztec software interdisciplinary material. We're trying to wrap up this section about finding coordinates and how they relate to equations and lines represented by equations. So, and these usually are on a coordinate plane, which are like the planes with the x and y axis and all the numbers on your y-axis, on your x-axis, all the integers. And when you find points, you just count the number of spaces for the x and y values on the coordinate plane. We just did this. We were just learning about how when you graph a line, you're able to find out if a certain point is located on that the line of that equation, or if it is not. And how you do that is whatever point you're given, like the point 1,5, for example, for x and y values, you can plug it into your equation, like y equals 2x plus 3. And if the equation comes out balanced or true, like if you get 5 equals 5 for that equation, when you plug them in, you will know that, in fact, that coordinate, those points of that coordinate are in fact on that line for that equation. So they are a solution for that equation. So for any number of points that they may ask you, you just plug it right into the equation, and you will come to the solution of whether that coordinate is on that line, or if it's just a random point floating around on your coordinate plane and is not on that line. So if you get a false equality, or you get two numbers that do not equal each other on either side of the equation for y and x, for the equation, you will know that number is not a solution for that line, for that equation. And then for the next section, you have a system of two linear equations. When you have two lines in the coordinate plane that cross, you will then have two equations, y equals x plus 6, for example, and y equals 3 over 2x plus 1. And it's given that the point 2, 4 is where these two lines meet. And so this point exists on both lines. If the point did not exist on both of the lines, then it would not be a solution to that system of lines. So the solution to the system is where the lines cross, or where they meet, is that point. Example, if you have those two equations that I just gave, you solve with the point that is given, and in the end, when you plug everything x and y's in, you get 4 equals 4. Therefore, the point is in fact the solution to that system, or both equations. Another example, y equals negative 5 over 3x minus 12 and y equals 4 over 3x minus 3. You solve for the point that they gave, which is negative 3 comma negative 7. You want to know if that point falls on both lines or is at the crossing point. You plug it in, the x and y values, into those two equations, and in the end you get negative 7 equals negative 7, which is true. Therefore, that line is in fact the crossing point of the equation system. Another example, y equals negative 3/4 x plus 5 and y equals 3x minus 4. Solve for the point 4 comma 2. when you plug those in for the x and y values in those two equations, you get 2 is 8. 2 equals 8, which is not a true statement. Therefore, that point that is given is not the crossing point and is not a solution to that system of equations. So it has to actually, it has to work for both equations. If the point works for one equation as an equality, but not for the second equation, that means the point falls on one line, but not on the other line. But that's not useful for us because we need to find the meeting point, which is the point for both, that falls on both of the lines. So for that previous equation, what happened was in the first equation, when we plugged in our x and y values, we got 2 equals 2, which is true. Then in the second equation, we plugged in the x and y values and we got 2 equals 8. So what it is you plug them in twice, and because there's 2 lines and the values that you plug in has to work twice for both equations or lines. If it only works once, it's not the crossing point. It may just be a point on that line, on one line, but we needed to fit in to both lines. As a note, 2 lines that are parallel and never cross, they have no common points, therefore they have no solution. So a solution is a coordinate or a point that you have that plugged into both equations gives you true statements both. If you have 2 parallel lines, for example, y equals 1/3 x plus 4 and y equals 1/3 x plus 1, these are parallel, so there's only like 3 spaces in the y-axis that differs between the 2 lines. They run parallel, they never cross, they never overlap. So that means that they do not have a solution. And on the other hand, if you have 2 lines with the same exact equation, that means they overlap at infinite points and have infinite solutions. Overlapping lines with the same equation. You use substitution to solve equations with 2 variables. You isolate the variable, as we noted earlier in the previous video. So one equation, plug in what you isolated, the term into the second equation you solve, then plug it back into the first, and you get the answer for x and y. If you plug in the points again back into their original equations, like the x and y values that you get as an answer, they should come out. They should work as true equalities. Sometimes you have to, in order to isolate the variable, you have to divide by common factors. So like if you have 8x plus 4y equals 48, simplify that to 2x plus y equals 12, dividing everything by 4. And then you isolate y on one side. You could either isolate x or y, and then here it's easier to isolate the y. You bring 2x on the opposite side, so you get 12 minus 2x. So the 12 minus 2x is the term you will plug into your second equation in place of y. And then you will get, when you go through the process, you will find what is x. So once you find the numerical answer for x, you will plug that into your first equation for y, and you will find the numerical answer for y, and that will be your answer. And when you find your answer, x and y, you write it in the format x comma y and put parentheses around it to show that it's a point on the plane, or a coordinate point, and that's your solution. Okay, so for x and y. So you can practice by doing equations. So two sets of two equations